In this section, we are considering several rules for combining probabilities. Let's look at the first rule, the addition rule. Given two events, A and B, the compound event A or B is a union of these two events, A and B. We can imagine a Venn diagram. So here we've got in one bubble the event A, and say in another bubble the event B. So together these two events are occurring in some universe or some sample space, if we like to think of it. And so the probability of the event A or B will be equal to the probability of event A, which we can imagine would be everything in that A bubble, plus the probability of event B, so everything in the B bubble, minus the probability of event A and B. So actually that would be everything in the intersection, right, which would be this overlapping region there. So we want to subtract that because in this case, when we added probability of event A and B together, that one was counted twice. Let's consider several possible ways that these two events could occur. On one hand, the two events may have no events in common. So in other words, they would be disjoint events. We can imagine two events that have no overlapping regions. So here, for instance, the events A and B would be separate. Versus events that are not disjoint would have some overlapping region. Okay, so they have this portion in the middle where the two sets have an intersection. So we say they're disjoint if they have no elements in common, so they're separate groups, whereas they're not disjoint, meaning they could have some events that occur in both. One example of disjoint events could be, for instance, we maybe have the event of an animal being a dog, or the event of an animal being a cat. So let's think of it this way here. If I have one bubble that represents cats and another bubble representing dogs, right? There are no elements that are common to both sets because an animal can't be both a cat and a dog. Let's think, on the other hand, if I have sets that are not disjoint, we could, for instance, have one bubble that represents dog owners and another bubble that represents cat owners. And in this case, there could be people that own both a cat and a dog. So let's think one bubble here would represent cat owners. And another bubble represents dog owners. And this portion in the middle would represent those that own both cats and dogs.